Hello everyone, my name is Yishu Qian. Today I will talk about the heat capacity study of fractionalized excitations in ruthenium-3 chloride. Um, so based on the study from Tremelli and Bias, I keep on the antiferromagnetic models. So ethylene humantinate is a mathematical model of the ferromagnetisms in statistical mechanisms. The model consists of discrete vibrators that represent magnetic dipole moments of atomic springs that can be in one or two states, so +1 or -1. In my model, I set my J value as the positive 0.001, and the interaction between the dipoles cause a magnetic ordering such that the vector sum of the spontaneous magnetizations of the substance vanishes, which defines at the antiferromagnetic state. So this figures is from the one of the papers, and this literature it compares their experiment result with the theoretic model running result. So the blue line in the figure, which is the result like the zero external magnetic fields, and the green line is the experimental record from their papers. So they get generally it follow the same trend of the experiment to the same as the theoretics, but without the peaks. So which means there's no heat entropy released. And also they run the coding of the temperature dependence of heat capacity of the spring excitations in the ruthenium-3 chloride, which is similar as what I get. So from my experiments, I changed the spring B values from 0.001 and 0.01 and 0.1 to see what's the difference between based on the spring numbers. When the B is increased and the peaks will be increased as higher temperatures, and the intensity of the peaks also increase with the B increased. The orange line represent the paramagnetic results as the reference to my antiferromagnetic experiments. So for the conclusion, based on the temperature dependence, the heat capacity with the temperature increase and then drops, which is because by the low temperature ammonia as being delivered from conventional spring degrees of freedoms, and the high temperature ammonia could indicate the Majorana ferments of the Katavi spring liquid. And the peak in the figure with the B increase at higher temperature. The intensity of the peaks also increased with the spring B increased. Those is caused by the ammonians are of similar nature and are related to the domains with the slightly different stacking order. And that's all for my presentation.
So any questions in the audience? Or maybe healthy homework criticism? Any?
Just clarification. Maybe this is something I just didn't stumble onto, but what are
Majorana fermion? Is that how you say that? Majorana. I think Steven is the one of the person in the class who can answer. Steven? Sorry.
Majorana fermions are a virtual particle that arises from interaction between states at low temperature.
What are their spins? What is the spin of Majorana fermion?
People
I would check.
Wait, so not all fermions have a spin of 1 half? Or this is a special case?
It is a special
Sure,
case.
okay.
Okay. Yep. Thank you. So, any Steven, you figured and discussed with John more questions to each in the class, in the audience, or in the online. So each I have one critical comment. Would you please go back a couple of slides? Back. One more back. So let's attract the attention of everyone in the class to this figure and maybe look on the labels. So what is labeled here and there? Which transition metal? Are they the same or different? Ichi?
They are different.
Yes. Okay. Thank you. And are they? You mentioned maybe by mistake that the one is theory and other is calculation. Would you agree that both of them are experimental measurements?
Okay. Yeah. I made mistake right here. Yeah.
Okay. So the one with rhenium is same ionic radius, same very similar atomic weight, but it doesn't have antiferromagnetic ordering. And then
Yeah.
heat capacity goes by the model that you studied in the first 2 months of the class, right? This Professor Burkhout, because of oscillations of nuclei. And ruthenium has very similar mass. It repeats the same curve, but in addition, there is a very sharp spike below 10 Kelvin because of change of magnetic modeling. So it is one experiment is reference to another experiment. And it was not a question, it was just basically like some suggestion for improvement if you do revision of the paper. Okay, and can you please go forward? One more. Yes. And the peak in the panel C that each has computed agrees qualitatively with the experimental data of magnetic ordering in the heat capacity. And it is main achievement that each has obtained through her model, which is really impressive. Okay, more questions to Ichi? If no, let questions. No questions. Let's thank everyone.